Alright, so I want to talk about the limitations of text. And as much as I am a text enjoyer, there are some limitations. Being able to operate on a piece of media or a workpiece in the sense of a string of data, I guess. We're talking about like a file of some sort. There are definitely limitations to text. One example that comes quickly to mind is imagine opening up an MS Paint document. You know, you draw a set of rectangles on the screen and then fill them in with various colors and then say, I'm Andy Warhol, because you are, essentially, at that point. And then open that file, that bitmap image that you just saved, open it up in a text editor, and then say, change the color there. And if you understand what thou readest, then you actually can do that. You can take an individual color which appears anywhere, a single color of the palette which appears anywhere within the file, and edit the hex values such that they will update that color to a different color. But it's not very instructive. We're talking about something that's a visual medium, a very visual medium. I was recently slightly annoyed by finding a PDF of dubious origin, and I was like, well, kind of don't want to open this up like in a PDF viewer in a browser, because if something's wrong with it, then I don't want it to do browser stuff, because the browser basically has near root access on your computer nowadays. It has peripheral access. It's insane. Never mind. So I wound up opening it up in a text editor, and it was just base 64 compressed. It's like, well, and there is probably a way within, base 64 is my guess, but opening up that file within Vim and then saying, hey, run this through a base 64 decoder and see what happens, that's doable. But I wasn't sure what I was reading exactly. So I saw a bunch of binary data essentially stored in base 64 and went, I don't know if this is the file. Like, I expected to find some words in there, and there were no words, 0 words. So I was like, it's a little suspect. So I opened it up in a specific dedicated PDF viewer on a Linux box. So there's no additional privileges. All it's going to be able to do is, display a PDF. And hey presto, it came up properly. So it was just a PDF, a regular PDF that was compressed into that base 64 format in order to just reduce the file size. So being able to, it would have been nice to be able to open that file up in a text editor and say, what are you? What's inside you? Although opening up in a hex editor wouldn't have done much difference anyways. It would have actually been less instructive. Because it all just would have looked like binary data. None of it was ASCII. There's a few, URLs in it that were ASCII, but, that's it. It's more about the source of the data than the actual content of the file. So, that was a limitation. Although, like I said, I'll mess with that later on maybe. But running it through a base 64 decoder within Vim is actually rather easy. I can find large blocks of that code, highlight it, and then I think it's : bang. So you hit colon and then hit the exclamation mark, and then you would pipe that to a base 64 decode command of some kind. And then it would return some form of output, and hopefully it would be text and not the text you're looking for, and not hot singles in your area are looking for you now, because they might find you. They're lurking. They're here somewhere. So that MS Paint document that you had open, the reminder is that within the storage of memory, and this is this is what you have to grok when you're making structs in C, is it's all just memory. It's all just one continuous stream of memory going on forever. And the only thing that makes that memory make sense is that you say, hey, every 25 or 24 bytes, you need to cut it off. That's one section of this array. Or after that 25 bytes, there's another 3 bytes of data, which accounts for, a long or something like that. And then after that, there's another 16 bytes that accounts for whatever. And that's all just you applying structure, struct, to what is essentially a long stream of ones and zeros. and in a useless stream of ones and zeros until you apply some kind of logic to it. Likewise, if you were to look at your lovely MS Paint image, you would find, 0, 0, 0, 1, 0, 0, 0, 0, just a stream of numbers for that first row of pixels, followed immediately by another stream of numbers representing that second row of pixels. And it gets kind of funny, because if you look at it in a frame of, or if you were to expand the frame of that image manually, then all the data turns to gobbledygook. It turns to a stream of colors, or let's just say ones and zeros. If you were to do a memory representation of a graphic in ones and zeros, let's say you're displaying it on an OLED display or something like that in a microcontroller, you're sending that stream of data to it. The stream of data ends at 64 pixels and then picks up at the beginning for the next 64 pixels. And if you take that slice of memory and you set the frame just right to 64, it makes an image. And if you set it to 65, every pixel shifts left once, the next line shifts left once, the next line shifts left twice, the next line shifts left 3 times, and you got like this mess. And it's funny because you wind up with this, something that looks like a QR code essentially, and then you expand the frame, and once you hit the right number of that frame, bloop, a picture appears. They suddenly have a logical order and make sense, and that's kind of cool. I don't know. It's cool when you do it, because because it's all just memory. It's all just ones and zeros within this frame, within a stream of data that you're applying some structure to. So there are things that almost must be done graphically. It must be done with your input, your visual feedback input. You're looking at things on the screen and saying, is this the right color for this? Is this the right place for this pixel? Does this make sense? And I find that interesting. And this is a measure, something for pixel artists as much as it is for anyone. Well, it's more for pixel artists than anyone doing any other kind of graphical, SVG, vector graphic style work, because the pixel, especially for our eyes, the pixel has a point of reference, and that point of reference is given by basically the entire luminance, the entire shading, the entire color palette of the image, and by the color palette of the pixels that are around it. So it's kind of interesting to think that a computer can generate an image and say, this is the color that this pixel should be, and humans can look at it and say, that doesn't look right. And the reason it doesn't look right is because our eyes are susceptible to these optical illusions, where something in a certain context looks like it's darker than the exact same thing in another context. These little optical illusions about the checkerboard and the cylinder, and the color of this checkerboard tile is this exact same as the color of that checkerboard tile, but one looks darker than the other because of the frame that's around it. So that's an instance where a computer almost can't perform. Aside from, predictive modeling based off of predictive modeling and like paid pattern matching based off of learning of other things that are similar. But that's something that is a strictly human experience. So that's also kind of neat. Now that I'm thinking about it, I wonder how those magic eye things are generated. All of that said, though, there is still a place for a text-based editing of something. So if you open up MS Paint or open up open up GIMP or Adobe Photoshop or something like that. GIMP might be able to do this. I imagine Photoshop could do it if you could speak the right language to it, but I know pretty sure GIMP can do this. Say you wanted to take all pixels of a certain color value and then flip their luminance if they're within a certain range. So imagine a shade of green. You wanted to make all the shades of green that were below the middle shade one step darker, and all the shades of green that were above the middle point one step lighter. Now that's something that would be basically impossible for you to do, for your eye to do within the image. But that is something where a computer program would work just fine. Now, the reason I say GIMP could probably do it is because GIMP has a layer, if I recall correctly, it's some kind of Lisp layer that lets you mess around, write scripting for it. So you can script controls for things you want to happen on the image, changes you want to make to the image, and you'd probably be able to do something like that. I only imagine Photoshop can do it because it's a powerful enough application, but I guess power does not necessarily indicate that you're going to get total control. You're going to have an API or a scripting console for any kind of thing you run into. So, I don't know. But I do know that if you have your palette values, it would be quite easy to run that into to take the hex of that file and run it through a little text processor or even a Vim text macro. I'm pretty sure you can do ifs. Maybe. Vim script sucks. I'm not going to mess around with that. But it would be pretty easy to figure out if this value is this, then update it to that. And if this value is that, then increment this section of it or decrement that section of it. This is something that you can do. So just remember that it's all just data. It's all just data. This is all just ones and zeros in a stream, in a memory block somewhere on a hard drive or within your RAM. And if you know what you're doing, you can do amazing stuff with it because it's all just data sitting there waiting for you to mold it and shape it, or give it an entirely new context, or squish the frame and turn it into QR code.